Hello, everyone. Welcome back to our final lecture on intelligent systems. This time we'll continue with deep learning. I'll give you an overview on some more advanced deep learning architectures, how they are being used for intelligent systems, and show you what the current state of the art is. So let's get started. The topic is still neural networks, or rather the modern version called deep learning. So remember where we started with a single artificial neuron, the perceptron. Then we moved over to a multi-layer feed-forward network, using the backpropagation algorithm. And then last time we went into deep learning networks by looking at the convolutional neural network architecture. And this has been one of the driving forces for the adoption and the hype around deep learning. So one of the applications is image recognition. I showed you the example last time where we used this small data set with 10 different image classes, the CFAR10. For research purposes, there is another well-known data set and corresponding competition, which is ImageNet. So there is a yearly challenge, like a competition between different approaches. There is a data set used by everyone, and then people over the years try to improve it. So this data set is a lot bigger. This is this is the 2012 edition I'm talking about. There are 10 million images with more than 10,000 different categories. So you can see this is quite a step up from what we did last time with 10 categories. Here is an example on a system submission. So you can see the image from the dataset. Then you can see the label. So this is what the system should predict. And then you see the top 5 predictions by the system. So you can see in the first row, the system got all the images correct. A mite, container ship, motor scooter, it was always the top prediction. And on the bottom, you can see 4 images where it got the wrong result. So here, this should have been a convertible. This should have been a grill, but it was predicted convertible. Here it's a mushroom. That was the second choice by the system. Well, this one is kind of mean because there is clearly a dog, but the expected one was the one in the front, the cherry. And here, well, it didn't find it in any of the 5 predictions. So what happened in 2012? As you might guess, there was a system that significantly improved the recognition rate compared to the other systems. So usually over the years, systems get better, every year, 1 or 2% or so, and systems are usually not that big apart. They all use the same, more or less, technology. So there were never that big differences. So systems had a 1 or 2% difference. But in 2012, one system was using the first deep learning approach to solve this. And this is what we now know as AlexNet. AlexNet, named after the creator Alex, PhD student at the time, who created this 8-layer convolutional neural network and trained it over a week or so, I think, on 2 GPUs. So this network has 60 million parameters. Took about a week to train, I think. You can see the publication is in the link here. If you don't see it in the video, if you go to the PDF, you can click on the link and you see his original publication. So this system beat all the other systems by about 10%, which was unheard of at the time. So this was significantly better than any other system. So that was the starting point for everybody moving from the classical machine learning approaches to deep learning approaches. And over the years, systems got better and better, although at the cost of bigger and bigger networks. we'll come back to that towards the end of this lecture. But that was one of the starts of the phase where people started using deep learning for image recognition, also speech recognition, video processing, and then later on natural language processing. So here in this lecture, I'll talk about a few more network architectures. I'll start with recurrent neural networks and LSTMs. And then in the last part, we'll talk about transformer networks. All right, so much for the introduction, and I'll see you back for part 2.